In connection with resistance and factors affecting resistance, let us discuss another important concept regarding to the resistance is resistivity. Is resistivity. Resistivity. So, in connection with the resistance and the factors affecting resistance. So, that is resistivity. Let us understand what is resistivity. So, as earlier in our previous session, we discussed the resistance depends on some factors. From that, resistance is directly proportional to the length and inversely proportional to the area of contact. Sorry, area of cross section. So, from this discussion, you can write R is proportional to L. We consider equation 1. So, length of the conductor. So, resistance is directly proportional to the length of conductor. Then also you can write R proportional to 1 by A is taken as equation 2 from this. Length of the conductor is directly proportional. Area of cross section is R proportional to 1 by A. From equations 1 and 2. From the equations 1 and 2, you can write R proportional to L by A. This should be taken as equation 3. R proportional to L by A. So, by combining the two relationships or from the equations 1 and 2, you can write R proportional to L by A. To remove some proportionality symbol, so you can write a constant value. After that, you can write R is equal to rho into L by A. Rho into L by A. Here the symbol rho. The symbol rho can named as rho. Is called as resistivity. Resistivity. So, rho is a constant. Known as resistivity of the material. Resistivity of the material of the conductor. Resistivity is also known as specific resistance. Resistivity is also known as specific resistance. So, from the equation 4, you can write as equation 4. From equation 4, you can write rho is equal to RA by L. Rho is equal to RA by L. So, now let us write all terms. So, rho is equal to resistance. R is equal to resistance of the material. A is equal to area of cross section. Then L is equal to length of the wire or length of the conductor. So, area of cross section of a wire or conductor. So, resistivity is one kind also known as the specific resistance. So, from the factors R proportional to L, R proportional to 1 by A, from equation 1 and 2. You can write R proportional L by A. So, then you can write R is equal to rho into L by A. can write rho is equal to RA by L. R is equal to RA by L. So the formula for this formula rho is equal to RA by L is formula for calculating the resistivity of the material of conductor should be memorized because it will be used to solve numerical problems. So finally, the resistivity of a substance or a material is numerically equal to resistance of the rod, resistance of the metallic rod or the conductor or the metallic wire of the substance which is 1 meter long and 1 square meter in cross section. Since the length is 1 meter and the cross section area is 1 square meter, it becomes 1 meter cube. So we can also say that the resistivity will now find so rho is equal to RA by L. If R is the resistivity, if R is the resistance, not resistivity, resistance. So if its resistance is 1 ohm and if the area of cross section is 1 meter square and if the length of the wire is 1 meter, based on that you can write units of resistivity. If R resistance is equal to 1 ohm, if A means area of cross section, if area of cross section is equal to 1 meter square, if length L is equal to 1 meter, this output is all, then we can write the units. So unit of resistivity is, so resistance ohm, area of cross section meter square by length meter. So square and meter get cancelled. Then finally we can write the unit of resistivity. So the unit of resistivity. Then the unit of resistivity is equal to ohm meter. Is called as ohm meter. You can write mass omega meter. So this is about the resistivity. So the unit of resistance R is ohm, then the area of cross section is meter square, then the length is L meter. So by giving all the units, then finally we get the SI unit of resistivity or specific resistance. Resistivity or specific resistance is ohm meter. The resistivity of a substance does not depends on the length or thickness. It depends on the nature of the substance and temperature. One of the very important one. So resistance depends on these factors. Whereas the resistivity depends on nature of the substance and temperature of the substance, but not depends on length of the conductor and thickness or the diameter The resistivity of a substance is a characteristic property. It is a characteristic property of material. So, materials such as copper are therefore used for making electric wires. Right. So this is about the resistivity or the specific resistance. Resistivity is the characteristic property of a substance. Resistivity is the characteristic property of a substance which can obstruct the flow of electrons. Whereas the resistance is obstructing the flow of electric property in a conductor. Right. Then after we will discuss resistivity. So the reciprocal of resistivity is called conductivity. The reciprocal resistivity is called as conductivity. So conductivity is the reciprocal of resistivity. You can write. So conductivity is equal to 1 by resistivity. 1 by resistivity, that is equal to 1 by rho. So you can write that is equal to rho is equal to, we know, RA by L. Rho is equal to RA by L. So you can write from that RA by L, you can write L by RA. So conductivity is equal to L by RA. So conductivity is the reciprocal of electric current. Somewhere has that matter also. Whereas the units of conductivity is mho. So resistance unit is mho. Then conductance unit is mho. Conductance unit is mho. Whereas the conductivity unit from this you can write. So meter by mho meter square. Meter get cancelled. by ohm meter. 1 by ohm meter. So 1 by ohm meter. 1 by ohm meter. So we can write mho meter, I think. So I will declare it. So the reciprocal. So the reciprocal of electrical resistivity is called as conductivity. Is called as conductivity. So based on this conductivity, materials are classified into different types. Materials are classified into different types. They are wood conductors, semiconductors, and insulators. So based on the resistance also we can do like that. Poor conductors, good conductors, semiconductors. So I shared a picture of resistivity of some common substances at room temperature at 20 degrees centigrade. So based on that resistivity, so the materials are classified into conductors, semiconductors, and insulators. So the values of resistivity of insulators are very high in the order of 10 power 14 to 10 power minus 16 ohm meter. For insulators, their resistivity is more, up to 10 power 14 to 10 power 16 ohm meter. Alloys like nichrome means the alloy of mixture of nickel, chromium, and iron, and manganese. So larger values of resistivity than those of materials. So metals has different resistivity. When different metals are combined and they form alloys, have different resistivity. Right? So the resistivity of alloys are much more higher than those of pure metals. For example, the resistivity of manganese is 25 times more than copper and So copper resistivity is 1.69. So for copper resistivity is 1.69 into 10 power minus 8 ohm meter. 10 power minus 8 ohm meter. But the resistivity of manganese, so which is made up of copper, manganese, and nickel, is 25 times more. So here copper is a pure metal, is individual metal. When this is mixed with manganese and nickel, it forms an alloy we can call as the manganese. Its resistivity is 25 times more than the copper. So the heating elements of electrical heating appliances such as electric iron, electric toasters are made up of an alloy rather than the pure metal because of the resistivity of alloys is more than the pure metal. The resistivity of alloy is more than the pure metal, and alloy does not go oxidation or burn easily at the higher temperature. As we know, individual pure metal may corrode, but the mixture of alloy does not corrode. And this metal, when the temperature of the pure metal reaches its particular temperature, it's higher particular temperature, they burn, they catch the fire and burn. Whereas the alloys, even the high temperature also they did not burn, just they turns into red hot. This they turns into red hot. So nichrome. Nichrome is one of the alloy. Nichrome. Nichrome is one of the alloy is used for making the heating elements of electric appliances such as electric toaster, iron, electric kettle, room heaters, water heaters, nothing but the geysers and hair dryers, because of nichrome has high resistance, high resistivity. Nichrome does not undergo oxidation, does not form rust, and it cannot burn even at the higher temperature. So just turns into red hot, just turns into red hot without burning or without breaking in the air. So the resistivity of conductors is very low. Metals, the resistivity of most of the metals increases with the temperature. On the other hand, the resistivity of insulators like ebonite, glass, diamond, very high, does not change with the temperature. So the resistivity of semiconductors like silicon, germanium, in between those of conductors and insulators. So semiconductors like silicon, germanium, these are the metalloids. These are the metalloids, have the intermediate properties between the metals and non-metals. And these metalloids acts as semiconductors, means in between the conductors and insulators, and decreases the resistivity of semiconductors decreases on increasing the temperature. So semiconductors are proving to be a great practical importance because of their marked changes in conducting properties to temperature. So impurity, concentration, semiconductors are used for making solar cells and transistors, diodes, transistors, solar plates. Solar cells are made up of semiconductors. So you will learn more about semiconductors in higher studies. Different kinds of semiconductors are there, so we will discuss. So finally, metals having low resistivity, then the alloys having more resistivity. So these are about the resistivity. So resistivity is the property. So this is completely about resistance and the factors affecting resistance. In that we discuss the another important one is resistivity. Thank you.